Welcome back to Algebra 1. Today we're going to be continuing with more discussion of properties of multiplication. We've done the commutative, associative, identity property of addition. Today we're going to be talking about properties of multiplication, but first, can you tell me why it is that the rubber chicken crossed the road? Well, she wanted to stretch her legs, of course. So, moving on, we are talking about properties of multiplication, and you'll remember that properties, mathematical properties, are things that are true, statements or equations that are true for any values of the variables, any number, no matter how great or how small it is. The commutative property of addition, of multiplication, is very, very much like, identical to even, the commutative property of multiplication. Addition said 2 plus 3 is the same as 3 plus 2. It doesn't matter in which order you add numbers. The commutative property of multiplication says order doesn't matter when you multiply either. 2 times 3 is the same as 3 times 2 because 2 times 3 is equal to 6. 3 times 2 is equal to 6. So when we turn that into a property where we're using variables to represent any number, we can say that A times B is equal to B times A. Remember, in algebra you bump up the variables next to one another, and that means you're multiplying. A times B is the same as B times A. It doesn't matter in what order you multiply numbers. The associative property, when we discussed that in addition, it said it doesn't matter in what order you group numbers together. When you're adding, you have the same result, which allows us to do convenient things like in a column of numbers we can recognize those things that equal 10, or in a row of numbers we can say, okay, I've got multiples of 5 here, or I've got hundreds or tens or whatever, and it makes it easier to do some mental arithmetic. The associative property of multiplication says the same thing. This says that if we have 3 numbers that we're multiplying together, it doesn't matter in which order we group those factors. We could say, okay, let's do 2 times 3 first. 2 times 3 is 6, times 4 is 24. Can see that little number there. 2 times 3 is 6. 6 times 4 gives us 24. Well, let's go ahead and instead of grouping the 2 and 3 together, let's group the 3 and 4 together. Gives us a new multiplication problem. 2 times 12. 2 times 12, we're definitely using different values than we are with 6 times 4, but our product, or the answer to our multiplication problem, is the same. 24 is equal to 24. So just as with addition, when you're multiplying, it doesn't matter how you group the factors together. You can only multiply 2 numbers together at one time. So group them any way you want, whatever is most convenient to you. And then using our variables, we have A times B times C. So if we have A times B times C, that's the same as A times B times C. So see, a lot of times what happens is that we get really intimidated when we see all of these different letters that are being used in math. We think, oh, I cannot get my mind about this when we're using these letters in algebra, actually. But it's just a way to generalize it. It says it doesn't matter what 3 numbers you're multiplying together. You're allowed to group them for multiplying ease any way that you want to because you have the same result. Our third property is the multiplicative identity. Now, when we had the additive identity, we said that if you start with the number and you add 0 to it, or you add nothing to it, you haven't changed the value. But this is a little bit different. What do we have to multiply 7 by so that we don't change the value of 7 so that our product is actually 7? Well, you're right, of course. You have to multiply this by 1. 7 times 1 is equal to 7. So the multiplicative identity property says that no matter what value you have, if you multiply that by 1, you do not change the value of that number. And this property right here is what you've used for years when you've been converting fractions from 1/2 to 2/4 to 3/6. Because you multiply by an expression that's equal to 1, so even though it looks different, it doesn't change the original value. A fourth property that we have, it's called the distributive property of multiplication over addition. And this says, okay, if I want to say 2 times the quantity 3 plus 4, that's going to be the same as 2 times 3 plus 2 times 4. And this one is a little bit different, but you sort of used this when you were doing expanded notation in multiplication. Here, 2 times the quantity 3 plus 4, when we use our order of operations that says what do I do first, we have to do what's inside parentheses first. So this becomes 2 times 7. Over here, we don't have any parentheses, but we have multiplication, which you have to do before you can do addition. 2 times 3 is 6, plus 2 times 4 is 8. So you have 2 times 7 is 14, is equal to 6 times 8, which is also 14. So this is called the distributive property of multiplication over addition. It's a very, very, very important one that we will use over and over and over and over and over in algebra. And the way that is written, let's see how I want to do this. I think I'm going to come over on this side. I'm going to step out of the picture for a minute. And this says that if we have any value a that we're multiplying against a quantity here, that is the same as first taking a times b, so we have that product, and then we add it to the product of a times c. So our distributive property tells us, distributive property of addition, distributive property of multiplication over addition, tells us that we can do our groupings differently here. This will help us be of immense value to us later. Finally, we have the zero property of multiplication. What happens if you multiply something by 0? What's 7 times 0 equal to? That's right. 7 times 0 is equal to 0. 10 times 0 is equal to 0. What is 9 times nothing? It doesn't matter how many times you say nothing times nothing times nothing. You still end up with nothing. So the zero property of multiplication that tells us that if you have any number a and you multiply that by 0, you're going to end up with 0. So in conclusion, I want to point out right here the difference in the multiplicative identity and the zero property of multiplication. Any number, any value times 1, the value doesn't change, but any time that you multiply any quantity by 0, you end up with 0. And that's the conclusion of this lecture.